In this video, I'm going to discuss the condition states as they pertain to wearing surface. And this includes all wearing surfaces, the rigid and the flexible, the asphalt and bituminous and the cementitious. This is our basic chart. As we move from left to right, we move from the green to red, and green is good, the yellow is fair, the orange is poor, and the red is severe. And I've bolded condition state 3 because that's where I'm going to begin discussing defects. And usually if there's distress on the wearing surface, there's a defect. Usually a good place to begin is placing that at least temporarily in state 3 and determining if it should scatter to 2 or if it should scatter to 4. So either side. So condition state 3 is a good place to begin. And this is table 73, the manual bridge inspection. Just to show you what we're going to discuss, this chart's available in chapter 9 of the manual, wearing surface, the condition state definitions, and you can see the green, yellow, orange, red at the top. To clarify, our deck is in this image on the left, and our approach items are on the right, and it's clearly delineated at that structural expansion joint so that there's a clear delineation between these items. And to further clarify, the deck wearing surface is a square footage, and it's the portion above the floor carrying traffic, and the approach wearing surface is the portion beyond. In this example, it's beyond the approach slab, and that gap, between the blue and the red square there is the approach slab. If there's no approach slab, then your approach wearing surface obviously begins at the bridge extent, and it goes a distance or a length beyond the bridge. Approach wearing surface is an each, and that was determined by committee. Approach slab is square footage. And approach slab, largely we're looking for any sort of settlement or some sort of impact due to the reinforced slab underneath. But certainly use this guidance, the wearing surface guidance, to help code and get the appropriate rating for approach slabs as well. It's the portion on top. To give you an idea of some of the discrepancies we see when we do wearing surface inspections, this is 4 different ways, 4 different maps, defect maps for the same bridge, and this was done in 4 different ways, 4 different ways to collect this data, 3 different inspectors, and then 1 non-destructive way. And so you can see some of the variance that we might get if we're not quantitative and objective. So I encourage inspectors to please measure and please be objective and take the extra time, especially when there's defects that could impact safety or could impact a poor rating. So in the same vein, just to do some mental math, because that's a large part of what we're doing when we're coding the wearing surface portion, take a moment and try to determine how much orange is there within this area. If you need to, hit the pause button on the video. Hopefully you're somewhere near 5%. And notice if we cluster all of these squares together, that it fills up one row or most of one row within this grid. And usually if you can cluster them mentally, cluster the deficiencies mentally, it will help you get an idea of overall area deficient. So this is what 5% scattered and 5% clustered looks like. Now if we up the ante a little bit and go up to 7%, this is what 7% looks like. And this is what 10% looks like. And 10% is right around when planning and programming start to get involved and discussions are initiated for, should we replace this wearing surface? Should we protect it? Should we, there's money discussions that should take place right around this 10% threshold, because you're getting beyond the diminishing return. You're getting the diminishing returns for patching and just the minor repair items. So that's what 10% looks like. And this is what 15% looks like. 15% is pretty significant, a large chunk of the area. 15%, if you remember when we used to do condition rating, condition rating the pour, the 15% is the tipping point. So this would be the tipping point for a pour versus a fair on the 1, 2, 3, 4 for condition rating. And again, if we cluster that, you can see that that's taking up 3 rows, still 15%. And what we're asking inspectors to do within condition state language is to not only say this much distress, this much not distress, but instead this much and severe, this much poor, and this much fair. So we're asking the quantities to be within one of the 4 condition states. So take a moment, hit pause on the video, and try to determine how much percentage is orange, which would be poor, how much percentage red, which would be severe, and how much percentage yellow, which would be fair. The rest, or the non-shaded boxes, are going to be all of your good or condition state 1. So take a moment. And I'm hoping your numbers came up somewhat close to the ones above, 9% fair or condition state 2, 6% poor, condition state 3, and then 1% severe. And if you're like me, it's easier to find the worst portions and begin coding the quantities within the worst portions and then begin moving into the less worse. And inspectors within SMS are able to code either the quantity in square footage or the quantity and percentage. You can toggle back and forth between the two depending on whichever is easier to get an idea or to quantify. So going back to our chart, you've got your stratification from left to right. And the guidance that we receive, national guidance from AASHTO, is whether or not that is effective. And effectiveness has a lot to do with what's underneath that wearing course. And starting with condition state 3, limited effectiveness is condition state 3. So limited, and then we'll see how these scattered. So, but first we have to answer what on earth does effective mean? Effective, really, wearing surface does fulfills 2 primary roles. It preserves what's underneath, and it provides a smooth transition, smooth riding surface. So preservation and rideability are the 2 functions of the wearing surface. Substantially effective is going to be condition state 2, and that's where, say for example, you have a patch and you have now a sound patch. That would be condition state 2. Fully effective, condition state 1, and something that's no longer effective would be condition state 4. Another example, condition state 4 would be, this is the top surface, and the next year this is the underside. So where you've got matching active moisture on the underside, unprotected structural elements matched with the top side, which would be something that looks like this. There's a patch upon a patch with the concrete rubble. Obviously the concrete vertical faces are abrading against each other, producing this white dust. So you've got your top side, underside. This is an unprotected floor, and the wearing surface was not effective. So in order to dump something into condition state 4, it has to be obviously bad on top or actively unprotected on the underside as well. So matching those up would be very important. The quantities that here have the asphalt patch, these quantities, this square footage that has the asphalt patch here would be condition state 4. Cracking is a defect that we look for in wearing surfaces, and again it goes back to if you've got cracking that is wide, something more than 0.05 inch, and these are dimensions that AASHTO has gotten from ACI. 0.05 inch would be condition state 3. And a good question is, how do we quantify a linear defect within a square footage condition state? So the guidance is do something that is quantifiable and repeatable. So if you look at the top surface, you've got your lane lines, you've got these zones. If there's certainly just one crack running the whole length, you could just do a 1 foot width along the length, that 1 foot time the length. But if they're spaced within 3 foot here, and you can quantify, just try to get an area that's repeatable and quantifiable. So the lane lines are going to be helpful there. And if it's no longer effective, again, dump it into state 4. This is a wide crack. This would be condition state 3. And the smaller cracks, the tighter cracks, state 2 and state 1. Rutting, state 3. Shallow rutting, state 2. Shallow is something less than 1 inch. Delaminations or an unsound patch would be condition state 3. If that delamination, if that patch is getting worse and worse, state 3 is where it should start. And something that is a sound patch or small delamination is going to be state 2. If there's some sort of traffic bouncing, now this image is probably a better example of condition state 4, where you have maybe a substantial traffic bouncing or even traffic that has to swerve to miss something. Obviously that would be condition state 4, that rectangular area, that square footage. And a very important note about wearing surfaces in condition state 4, you'll note or remember that for national bridge elements or structural elements that carry live load and dead load, that carry load path, whenever we dump something into state 4, it would then trigger an analysis. And within that 90-day period, that reviewer was responsible for getting an analysis done and deciding whether or not that quantity should be moved back to state 3. That's not the case with non-structural elements, or in this case, wearing surface or the bridge management elements. They're not carrying, they're not responsible for transmitting live load through the load path. So once its quantity goes into state 4, it can stay there. There's no analysis period. There's no number crunching or structural analysis that's required. So that's an important note, the difference between national bridge elements and bridge management elements, or national bridge elements and agency developed elements. There's not that back and forth from 4 to 3. This concludes the wearing surface discussion. Should you have more questions, please refer to Chapter 9 of the Manual Bridge Inspection, and currently this chart for wearing surface, the guidance is on, for element level, is on pages 187 and 188.